Hello everyone, I welcome you all for this part 2 session on AdaBoost algorithm in machine learning. Today we are going to implement this algorithm from scratch using the Titanic dataset. We have already covered the theoretical and intuitive details of AdaBoost algorithm in previous session. If you don't have a bright idea about that, I'd highly recommend you guys to go through that video. You'll find the gateway to that video resource in both I button and description. Alright. That being said, let me tell you a little about the agenda that we have over here for this particular session. We'll begin this session on a friendly note by looking into overview of AdaBoost algorithm. Once done with that, we'll directly dive into the hands-on demonstration of AdaBoost algorithm. I hope you guys are clear with the agenda. Now let us begin with the first agenda pointer on our list, that is overview of AdaBoost algorithm. So we know that AdaBoost or adaptive boosting is a boosting ensemble technique that combines multiple weak classifiers to create a strong classifier. The idea behind boosting is to sequentially train weak classifiers or weak learners and focus on the instances that are challenging to classify correctly. Have a look at this image over here. What this algorithm does is it constructs the first weak classifier across the complete dataset. Then it computes the total error amount of say using which model generates the new weight values. Next, the weighted Gini index is taken to consider which feature should be chosen for classification. This feature will basically be used to construct another weak classifier, which emphasizes more on getting misclassified samples right. And this learning continues until the pure classification is achieved on the training data. In a basic sense, that's how AdaBoost algorithm works. Okay, one more thing that we can conclude from this image over here is that in AdaBoost, weak classifiers learn the pattern in sequential modeling, and that is the reason why it is considered as boosting algorithm. So let me list the properties of AdaBoost algorithm you should know before we delve into its implementation. First property is AdaBoost trains weak learners sequentially. Then another property is with each iteration AdaBoost tries to classify samples those were misclassified by assigning them higher values of weights. That is the reason why it is called as AdaBoost algorithm or adaptive boosting algorithm. What it does is it adapts to the misclassified samples and then assigns them high weight values so that there will be more emphasis on getting these particular instances as a right predicted ones. The strategy of weighted Gini index is used to decide on which feature to choose for classifying the data using weak learners. The fourth property that we have over here is that at every iteration or creation of weak learners, we end up boosting the weights of the misclassified instances so that the next particular weak learner will do a better job on them and so on. One more thing I want you guys to understand from above pointers is that AdaBoost algorithm is totally going to freak out if there is influence of outliers or wrongly labeled data, because if the instance is misclassified, AdaBoost is going to increase the weight of that particular instance to get it right. But doing so, it is going to affect the model's overall performance. So it is critical that you either visualize data to check whether there is noisy data available in it and deal with it using outlier detection and mitigation measures. Okay, now that being said, I think that's enough of an overview. So moving further, let's visit the code editor and begin with the implementation part. But before going there, let me tell you about the data that I'm going to use over here. The dataset that we are going to use for today's exploration is taken from the Kaggle. The name of the dataset is Titanic dataset. You can find the link to the dataset in description as well. So here we have data in train and test samples. So train CSV and test CSV. In the overview section, you can find the detailed explanation about the problem statement and what challenge is all about. But if you look closely at the data, you'll find out that we have multiple columns representing data about people who were on board the Titanic ship. Using this data, we are supposed to classify whether provided test instances will survive or not. So basically, survival is going to be our label. However, we have three different values for survival over here, that is 0.033, 1 and 0. Hence, we can conclude that there are three classes over here to be specific. And to get a classification decision, we have these multiple features given over here, such as passenger ID, then class, then name of the person, the sex, their age. Then we have multiple features such as the fare he paid for the ship, the cabin he sat inside, as well as he traveled alone or with family, etc. I hope now you guys are clear with what data contains and what the problem statement is all about. So let us visit the code editor and get started with implementation. Alright, let us begin by importing our dataset to the console. And to do that, we'll have to upload the data over to Kaggle runtime environment for first. So let us do that. I have already downloaded the data from Kaggle on my system. So I'll simply go to the directory where I have downloaded it, and then I'll upload it to the Kaggle runtime environment. Now I have successfully uploaded those files to the runtime. So I'll import them into the coding console. For that purpose, I'm going to require the pandas library for first. So I'll import it, and then I'll use pd.read_csv function. I'll save this inside train name data frame, and similarly I'll get the test data set over here. Alright, let me run this block. Okay, let us visualize if our data has been loaded into train and test data frames. For that purpose, we'll simply print them on our screen. So train and test. So we can see that there are 891 records in train and 418 records in test sample, and they have been successfully loaded into our Colab notebook. Now the next thing I want to do is I don't want to operate on both train and test data segregation separately. So simply what I'll do is I'll combine both train and test data frames using pd.concat method. So I'll store them inside data frame named as df and apply pd.concat method. And inside it I'll pass both train and test, and I'll set sorting to false. With this command, I think our data must have been loaded into the df. So let us validate by printing the df. Alright, here you can see that we have 1309 rows. That means train and test samples has been combined over here. Now next, let us import few important dependabilities that we are going to require down the line. So first I'll import numpy as np, then I'll import cborn as sns, then we'll import matplotlib dot pyplot as plt. Okay, now let us run this block as well. So now we have stored our data inside data frame named as df, and we can see that there are 1309 rows and 12 columns, but we don't really know a lot of information about our data. So initially what we'll do is we'll use info function to gather the data about if there are any missing values in our data set and what are the data type particular column has. So for that purpose, we'll be using this info function over here. Here we can see that we have different data types for different features in our data set. For example, passenger has integer data type, survived has float data type, sex has object data type, and so on. Besides that, we can also note that there are 1309 records in our dataset, but that's not the case for all the features in our dataset. For example, survived has only 891 values, age has 1046 values, cabin only has 295 values. So basically there are null values inside our dataset and we cannot allow them to be there because that is not feasible, right? So next thing what we'll do is we'll print the overall sum of null values across each and every column. For that purpose, we'll be using this command df.isNull.sum, and here we have nice tally of null records inside our dataset. Here we can see that age has 263 null values, cabin has 1014 null values. What that suggests is it is more than 75% plus empty, which means majority of records for this feature are missing. So without a doubt, this particular feature would not participate towards learning. Instead, it would impact the performance of model that we build. Also, value imputation is meaningless for this feature, hence we'll be better off without this particular feature. So I'll simply drop this feature from our dataset. For that purpose, I'll be using df.drop function, and inside it, I'll simply pass the name of feature, that is cabin, and we'll set axis equal to 1 because we want to delete this column itself, and we'll update our data frame. Now next, all other features have missing values for less than 25% of overall feature size. That is why we can impute values for them. To get that done, we'll simply import the value imputation method known as simple imputer. So basically this imputer will use strategies such as mean, median, mode, most frequent to replace nan values, and since these values are the ones sitting towards the center of distribution or are among the most frequent ones, they won't have any negative impact on learning procedure of our model. Alright, now that being said, let's get the age column sorted. First, let me get the simple imputer over here. So from sklearn dot impute import simple imputer, then we'll print the number of null values inside this column, number of null values in age column before imputation, and we'll get the value count. Next, we'll create the instance of simple imputer, and initially we'll set the strategy to mean. Now we'll transform our data using fit underscore transform method. One more thing I want to remember is that while passing column in fit underscore transform, make sure that it is a 2D object. If you pass it as a series object, it will throw an error. So simply use two embedded boxes over here, and we'll save the changed values into the column df age. Also, we'll print the number of null values after value imputation. Okay, let's run this block. Oh, I made small mistake over here. Okay, same here. And here you can see that we have successfully generated values for those 263 null records. Alright, now let us transform the survived column as well. So what I'll do is I'll simply copy this statement over here, and instead of age I'll put survived column over here. Alright, now there is only one column left which contains nan entries, that is embark column, but the data in this column is not of numeric type. So we'll change our strategy for simple imputer. Here what we'll do is we'll use most frequent as a strategy. So we'll have to create another instance of simple imputer, and we'll pass strategy as most frequent. Now we'll transform our embark column. Let's copy this line over here. df embarked c1 dot fit underscore transform df embarked. Let's run this block as well. Now let us validate if all the null values has been dealt with or not. For that we'll simply type the command df dot isNull dot sum, and here we can see that there is one value left for fair. So we'll transform this fair as well. So I'll copy this line, and instead of embarked I'll use fair. With that, we have successfully dealt with all the missing values in our dataset. Also, one more thing that I want you guys to note is we also have some verbose features in our dataset. For example, name and ticket. So these particular features are not going to support any sort of learning. So there is no meaning in keeping them inside our data frame. Thus, in the next phase, what we'll do is we'll drop these columns from our dataset. So let us drop them. For that purpose, we'll use df.drop method, and we'll pass the column names over here, name and ticket, and we'll set access equal to 1. Also, we want to update the state of our data frame, so we'll store it in data frame. Now let us view the current state of our data frame. Okay, now here we can see that our dataset looks somewhat clean, but we still haven't validated if there are outliers in our dataset. In the beginning of this session, we talked about importance of outlier detection. So basically, we won't want any outliers in our data, because if we have them there is possibility that the AdaBoost will assign more weights if they are misclassified, and that will completely impact the performance of our model. So we must perform the outlier detection for our data. Here we just have two numeric features, so we can only find outliers for these features, right? So what we'll do is we'll use the strategy for outlier detection named as z-score. So let me tell you a little bit about z-score. So this z-score helps to understand if a data value is greater or smaller than mean, and how far away it is from the mean. More specifically, z-score tells how many standard deviation away a data point is from the mean. In a normal distribution shown here, it is estimated that 68% of the data lies between plus and minus 1 standard deviation, and 95% of the data lies between plus and minus 2 standard deviation. whereas 99.7% of data lies between standard deviation plus 3 and standard deviation minus 3. What that means is this 0.15% of data that comes after the threshold value of 3 standard deviation can be considered as outlier, and it is what that is going to impact the learning of our model. So if I have to deal with any data that will be greater than 3 standard deviation value, so basically our threshold value is going to be 3, right? So let us set our threshold value as 3, right? And we'll load the function named as z-score in order to get the z-score values for these features. So from scipy dot stats import z-score. Besides that, we only have two numerical features, that is fair and age. Now we'll compute the z-scores. We'll round them up with np.abs method, and inside it we'll carry the z-score operation. Z-score will be calculated for these particular numerical features. And we'll print the z-scores. Alright, here we can see that we have successfully calculated z-score values for these numerical features. Now the next thing will be to see if those particular samples are outliers or not. And to detect that, what we'll have to do is we'll have to carry out comparison with our threshold value, that is 3. So if the z-score value is above 3, then definitely that particular sample is going to be an outlier. So let us apply one condition for that purpose over here. So outliers will be np.where z underscore scores are greater than our threshold value. We'll print these outliers over here to see if they are there or not. And here we can see that there are quite a number of outliers available in our data. Now, how we deal with them? The mitigation of outliers can be done with function named as winSoRize. So winSoRize is a function available inside library stats.mstats. So basically, let me load it for the first from scipy dot stats dot mstats import winSoRize. So this winSoRize function requires two parameters: the data from which you want to remove outliers and limits. So basically limits is the positive and negative area of distribution that winSoRize will simply convert into something that is close to the mean. So let us apply this winSoRize method. winSoRize df age, this will be the data part that we talked about, and then comes the limits. So we saw that 15% of data is considered as the outlier part, so we'll pass limits as 0.15 positive and 0.15 negative. Alright, and we'll store this result inside df age. Basically we are updating it. Now we'll do same for another numerical feature, that is fair. So df fair equal to win-so-rise df fair, and we'll keep the limit same. Now let me run this command. Alright. Now let us see if we have removed some outliers from our data or not. For that purpose, we'll run this command again. And here we can see that we don't have any sort of outliers in our data now, because the arrays are empty over here, right? So outliers does not contain any outlying records. So we have successfully dealt with outliers in our data. So now let's move to the next thing on our list, that is encoding. So initially we saw that there are few samples in our data that are of object type. So we'll have to deal with them. For that purpose, we'll use the ordinal encoder. So let me load this ordinal encoder over here from sklearn.preprocessing import ordinal encoder. Now we'll instantiate this encoder. OE is equal to ordinal encoder. Now we'll transform a sex column for the first. OE dot fit underscore transform sex column, and we'll update the state of our current sex column. Now let me run this command. Alright, let us see the state of our data frame, and here you can see that the sex column has been converted into ordinal numeric values. Alright, now similarly we'll have to do the same for embark column as well. So let me do that. We'll basically copy this command over here, and instead of sex we'll just put embarked as a column title, right? Embark. Now let me run this command. Next, let us look at the survive column, because we initially saw that the target variable is not of ordained numeric values. These are kind of float values, so we'll have to convert them into ordinary values as well. So again, what we'll do is we'll apply this fit underscore transform method to them as well. Alright, now let us see the state of our data frame. So here you can see that we have successfully converted data into ordinary values. So now the next thing we'll do is we'll convert our data into input and output vectors, that is x and y. So basically the x will contain all the records except the survived feature. So x will be equal to df dot drop survived and access equal to 1, because it will just contain the features, it won't contain the target, that is our survived feature over here. And y will just contain the survived feature, right? Alright, now next we'll import train, test, split and convert the data into training and testing sample. So from sklearn dot model underscore selection, import train underscore test underscore split. X underscore train, comma X underscore test, comma Y underscore train, comma Y underscore test will be equal to train underscore test underscore split X, that is input vector, Y, that is output vector. Then the test size will set will set test size to 30% of overall data, and random state to 0. Alright. Now we have successfully segregated data into training and testing samples. So our data is completely ready and we can feed it to any model now. So without wasting any time, let us import the AdaBoost classifier and get the classification done. So let me import this AdaBoost classifier from sklearn.ensemble import AdaBoost classifier. Next, we'll instantiate the AdaBoost classifier function. So AB is equal to AdaBoost classifier, and here you can see that we have multiple parameters for optimizing the performance of AdaBoost. So for now we'll set them randomly. First we have n underscore estimators. So this parameter basically resembles the number of weak classifiers you want to create. By default this number is 50, so let us set for 45 right now. Then we have learning rate, which will set to 1 initially, and random state, which we set to 0. Now next we'll fit our training data to this model. So ab dot fit x underscore train, comma y underscore train, and we'll create the predictions and we'll store them inside variable named as y underscore pred. ab dot predict x underscore test. Now moving ahead, let us check the accuracy of our model with the help of accuracy underscore score function. But first we'll have to import it over here. So from sklearn dot metrics import accuracy underscore score, and we'll print the accuracy score by compare y underscore pred and y underscore test. And here you can see that we are getting 76% accuracy. Now let us change the number of estimators to 100, and still we are getting the 76% of accuracy. So you can play around with these particular parameters that we have over here and try to see the way to get the accuracy higher, but that is the task for you guys for now. I hope the concept that we covered through this session are clear to all of you guys out there. You can practice more about AdaBoost algorithm and its optimization on your own by picking up datasets from UCI machine learning repository or from Kaggle. Also, make sure to try your hands on hyperparameter tuning. That's all I have for you guys in this particular session. If you have liked this video, do make sure to hit that thumbs up button. Also make sure to subscribe to Intellipaat YouTube channel to come across multiple tech updates coming from our end. On that note, Goodbye until next time.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.